So just a quick review of these, just to like look over. Okay, we have all these double angle formulas. They are a lot easier than the half angle ones. Sine and tangent, relatively easy. Cosine, there's 3 options to pick from. It's just going to come down to pick which one's the easiest one with a given scenario. And I know that at this point, you're like, well, how do I know which one's easier? It's not really a trick to know which one's easier. It's just sometimes you just got to just pick one and go with it. Just depends on what you're given. Half angle formulas, definitely the harder ones. I will tell you the signs of them that you need for the problems that I'm going to give you, just to make it a little bit easier, just because it can get a little bit confusing with that. So just to start with just an example that's not one of the like homework problems, but just to try to make things a little bit easier. If we have the cosine of 165 degrees, okay, we still want to look and see, like, is it a known value? If it's not, then we need to do something else, okay? And that's obviously not one that we know, so I need to find something else that I can do this with. I'm going to do this one as a half angle because, like I said, it's a little bit more difficult, so I'd rather, spend a little bit more time with those. So I can treat this as, I'm going to look for an a over 2 value. So I'm going to look for a value for a, preferably one that I know, okay, that I can half, and it give me 165, okay? And then I need to know if it's positive or negative, that value that I'm looking at. So, because I don't know that yet. So what value would have to give you 165? So we're going to look at the cosine of half of 330 degrees, okay, and this is A, okay, 330 is A, so A over 2 is that. Now, just to go back, the quadrant where A over 2 is the sign that we're looking for. So I'm dealing with the cosine of A over 2 is 165. So where would that fall? And would it be positive or negative? I want this value. Is this value positive or negative? Because where does it fall? Quadrant 2. So is it positive or negative? Cosine value.
Oh, negative.
Negative. So I'm going to choose the negative one. So it's going to be negative square root of, and then just look back at the formula for cosine. Okay, it's 1 plus the cosine of A over 2. So 1 plus the cosine of 330. Okay, because remember, this value is my A value. All over 2. So then we want to replace the cosine of 330 or whatever that would be. Okay, give us a different problem. Okay, we want to replace that with the known value that we have off our unit circle. So what is the cosine of 330? Okay, so 1 plus root 3 over 2, all over 2. Okay, so in terms of the top, I'd really like to get a common denominator because it's going to make my life easier. Okay, this is where once you have it set up, it's just a lot of algebra, which can get really annoying. But it's not like completely awful. So I can rewrite 1 as 2 over 2. Okay, so then I have the common denominator of 2. So I can do 2 plus the square root of 3 over 2, all over 2. Okay, your all's favorite, all over. Okay, then because I'm dividing by something, it's the same as multiplying by that thing as a fraction. Okay, so I can treat this then as, let me write it so that way y'all can see it, and then I'll pause for a second. So 2 plus the square root of 3 over 2 times 1/2. Okay, so the only thing I did from this step to this step is that I rewrote the dividing by 2 as multiplying by 1/2. Okay? Y'all would agree with me that that's the same thing, right? Okay, great. So then, now because I'm multiplying these two fractions together, okay, the one on the top isn't doing anything to the top, but the bottom is going to become 2 times 2, which is 4. And it will get to the point where, like, if some of this stuff you can do, like, all in one step, I'm okay with that so that it doesn't take up, like, 18 lines on your paper. Totally fine. I just want to show every step right now so that you have it if you look back on it. So this would be the square root of 2 plus the square root of 3 over 4. I think we've done, or at least you should have seen at some point, probably in Algebra 1. I know that was the COVID year, so you may not have hit that material as well. But if I have a radical that's covering top and bottom, I can split it into 2 separate radicals. Okay, so this right here, I'm going to just do this to the side just so you can see this is equivalent to 2 plus the square root of 3, or the square root of that, over the square root of 4. Okay, I can take that one radical and split it top and bottom. Okay, and then the bottom becomes what? Okay, that's just 2. So then I have negative square root of 2 plus the square root of 3 all over 2. Okay, and then that would be my final answer. Okay, so kind of see what I mean? Like, the initial setup is a little bit weird for your half angle formulas, and then as far as after that, it's just the math is weird. The algebra is just a little bit confusing from there.
Okay, so like third step, when we had negative root 2 plus root 3 over 2 all over 2, and then it went to that times 1/2, where we get like the 1/2. I know it has something to do with the 2 on the bottom.
So we divided by 2, and dividing by 2 is the same thing as multiplying by 1 over whatever that number is. You got one side. I got 3 sides and got really excited.
And then it didn't happen.
Then it just didn't happen anymore. It's okay. I've
gotten close so many.
I got this one too, and I've solved this one 4 times already.
Really?
All right, let's see. Another example. I don't remember if I mentioned this before break, but even if I did, the odds that you remember this are pretty slim. So if you have the value given in radians, because finding like half of the radian value can be a little bit weird, you may want to convert it to degrees. Actually, I would highly recommend you convert it to degrees. Makes your life a little bit easier. So that's what we're going to do with this next one. It's another one that's just an example, not specifically in the thing. So the tangent of pi over 12. Okay, not that you couldn't do this. Like, I mean, like, what value taking the half of it gives you that. Like, not that you couldn't do it, but I just think, like, some of them are not going to be that just, like, plain and simple to, like, think about, and they're not always going to be values that you know. So it's like, why don't I convert that to something that I do know? So I'm going to convert this from pi over 12 into degrees by multiplying by 180 over pi. So what does that give me in degrees? What?
Wait, are we dividing?
Well, so the pi's are going to cancel, so I need 180 divided by 12.
Yes. Yeah, 15 degrees.
15, yes. Sorry, I'm getting a lot of junior senior questions, and I was like, I'll answer them later, though. It's the first day back from spring break. Just need a second. All right, so I'm dealing with the tangent of 15 degrees, not a value that I know, okay? Again, I'm going to use the half angles just because your book doesn't do quite as many that are half angles. They do a lot more with the double angle ones, so trying to keep it a little bit to give you examples. So my a over 2 value, Okay, what would my A be?
30.
30 degrees. Okay, so A is 30 degrees. So I can rewrite this as the tangent of 1/2 of 30 degrees. So I'm going to look up here again at my formula. Oh, wait, there we go. Now these ones, doesn't matter positive or negative. Okay, tangent is just this no matter what. It really doesn't matter which of these two formulas you pick. I would say try to keep the denominator as simple as possible if it doesn't matter which one you use. So I'm going to use this 1 minus cosine of A over sine of A, so that way I'm not dealing with like the 1 minus a whole bunch of stuff on the bottom that's going to cause me to flip it. But regardless of which one you pick, you should get the same answer. So just, if you're like, no, I like the second one, you can absolutely use the second one. Be my guest. But anyway, so that formula, I have the 1 minus cosine of A, which is 30, over the sine of A, so sine of 30. So then tangent ones are actually the easy ones for these, well, for the most part, other than like moving stuff around, but they don't have a radical and a radical and all that fun stuff. So I've got 1 minus, what's the cosine of 30? 3 over 2, all over, sine of 30, 1/2. So now, same thing like I did on the last one, I want to get that common denominator on top to simplify things as much as possible. So I'm just going to end up with, okay, this 1 can be rewritten as 2 over 2. Okay, so when I do that, then that's going to give me 2 minus the square root of 3 over 2, all over 1/2. Now, divide by a fraction is the same thing as doing what? Multiply by the reciprocal, or if you have my mom, keep, change, flip. So 2 minus the square root of 3 over 2 times 2, okay, over 1. And so then the 2's cancel top and bottom, leaving you with 2 minus the square root of 3. Nice and easy. Not as bad as the radical and radical like we had in the other one. Isn't that kind of annoying?
It is.
They have one that's like that, but it's all black and white. But it only fits together one way. It's called a ghost cube.
Ew. Who thinks up these cubes? Like,
I don't know, but
People that want to watch the world burn.
I left that one just like sitting in its box for like several days because I just was too stressed out about mixing it up. And now that it's mixed up, it's kind of annoying.
Just look up like tutorials.
Yeah, for real.
I can, so that way it's right here. It's so annoying.
I know, well, once you get like, I had 3 of the sides, but it was like to do anything else, I had to mix up the 3 sides that I had because they were all touching. So like the only way to do it was to mix up the sides I had already solved, and I was like, so, ugh. There was a cube like that, but it's like magnetic, but it was like an actual like cube, and it was like $60, and I was like, why? I was like, why is it so expensive?
Some people, if we're gonna, honestly though, this is just a big puzzle. If I want to do an actual puzzle and spend a lot of money, I want something that's like actually fun.
Oh, yeah.
Pandora's box, stuff like that.
Decimal.
Can I see the other one?
Are you gonna mix it up on me?
Yeah.
It's okay, I can solve it.
Thank you.
I actually solved that one really quickly. All right, so some of these problems, okay, you will be able to do like 2 different ways. You could do it by using a double angle, or you can do it by using a half angle. There are like a few where that will work for. But this one, obviously, I don't have a double angle thing that's going to give me something with a decimal. So this must be a half angle. So what cut in half gives me that 112.5? What?
225.
Yeah, sorry, I just couldn't hear you. All right, so I'm going to treat this as the tangent of half of 225. And then let's mix it up. Let's use the other formula this time. So let's do the sine of 225 over 1 plus the cosine of 225. So what is the sine of 225?
1 second. Negative 1/2. Negative root 2 over 2.
Negative root 2 over 2. Oops. Come on. All over 1 plus cosine of 225. Negative root 2 over 2. Okay. Now, same is going to apply. I want to get that common denominator on the bottom now instead of the top. Okay, so the negative root 2 over 2 on top stays the bottom. Okay, I can switch out this 1 for still 2 over 2. So the bottom becomes 2 minus root 2 all over 2. So now I'm dividing by a fraction. It's a different kind of looking fraction, but I do the same thing. I'm just going to flip it. So that's going to give me negative root 2 over 2 times 2 over 2 minus root 2. I'm going to let y'all get there for a second, and then I'll keep going. No, I cannot. And that's why I decided to pause, because I wanted to make sure that didn't happen. So, when you get here, okay, the 2's here and here can cancel. Actually, here, let me do those with a different color. These can cancel, okay? These, however, cannot. That's not true, okay? Okay? Because this one down here on the right is 2 minus root 2, I cannot cancel the 2 root 2's. Okay, so this is minus the square root of 2 over 2 minus the square root of 2. But that's not allowed. Why?
There's a radical on the bottom.
The radical in the bottom, so how do I get rid of it?
You multiply the top and bottom by 2 plus root 2 over 2 over 2 plus.
Okay, so I'm going to do that. Now, had I chosen the other formula, I might not be going through all of this. It's kind of hard to say at the moment, but it's still a possibility. It might not be as difficult, I don't know, but who likes the easy way out? Just kidding.
Everyone does.
All right, so multiplying the top, I'm going to end up with negative 2 times the square root of 2. And then negative root 2 times root 2. Well, that is the square root of 4, which is 2. So that's going to give me minus 2 over, or all over. Okay, on the bottom, what do I have?
4 minus 2.
Okay. Or a difference of squares is what I was looking for, but okay.
Sure.
So yes, that is 4 minus 2. Okay, the square root of 2's cancel and the other pieces go away. That's why I was going for the difference of squares, but that's fine.
I got there. I just.
So then, that was fine. I was just seeing if y'all would. In Algebra 1, they don't always know what they're doing, but it's so funny because if difference of squares, they're like, difference of squares, like all the time. And I'm like, okay, whatever. It's not a difference of squares, but glad you think so. So this is negative 2 root 2 minus 2 all over 2.
Whoa.
Am I done?
No.
No. I can take a 2 out of the top. Okay, so that's going to give me 2 times negative root 2 minus 1 all over 2. Okay, and I do it this way because I don't want you to think that I can just cancel just to cancel. Okay, because that top has 2 pieces, a 2 has to come out of both for me to be able to cancel it. Okay, and that's a really common mistake, and I don't want that to happen. That's why I'm showing it to you this way. Okay, so now because I was able to take a 2 out of both pieces on the top, I can cancel these 2's out. And then my final answer, after all of that effort, is minus the square root of 2 minus 1.
That's such a weird answer.
Just a little bit.
Can't say I love this section.
Huh?
Can't say I love this section.
Yeah, it's, you know, it's a section.
Yeah, it is.
Did you solve it, Jake? Not really. I don't want to mix it
Was
up.
that one like easy?
It's
to
okay. I know
solve?
how to. I've solved it 4 times. So if you mix it up and it gets stuck, I can get it back.
Is it easy to solve or did you just? solve it?
No, but there's a trick to it. So like once you know the trick, it's really easy.
Oh.
But I'm not gonna share the trick. So.
Share the trick.
All right, next one's gonna get a little bit more crazy. Got a negative angle. Number 6 is the cosine of negative 75 degrees. So 75, not a known value. Apparently the book actually likes they do stuff with double angles, but these kind they typically are doing with the half angle. So we're just gonna spend a lot of time with half angles today. That's what we're gonna do. So cosine of negative 75. Half of what gives me negative 75 that also happens to be a known value? 150. So this is the cosine of half of negative 150. Now, negative angles are not our friend because that means we have to go like backwards. That just sounds like a lot of work. What can I do to make it positive?
At 360.
At 360, if I do that, what do I have?
Whatever you get.
210.
210. Okay, and y'all would agree with me that negative 150 is the same as 210?
I would.
Okay,
Yeah.
great. Now, I need to decide positive or negative, okay, based on where my original angle is. Okay, that original angle is in what quadrant?
3. Wait, what angle?
This one.
3.
Oh.
Where's negative 75?
1. No.
Negative
Wait.
75.
4.
4. Okay, what x values are what in quadrant 4? Positive or negative? Positive. So I'm going to choose the positive one for cosine. Okay, so it's going to be positive square root of, and I want you to be intentional the first time you write it about writing the sign that goes with it. Okay, positive or negative. If it's positive, you do not need to continue writing it all the way down. If it's negative, obviously you need the negative sign all the way down. Okay, so formula 1 plus cosine of A, which is the cosine of 210, all over 2. So cosine of 210 is what?
Negative root 3 over 2.
Okay, so 1 plus negative root 3 over 2, all over 2. Okay, so like I said, I'm not going to keep carrying down the positive sign. If you want to do it just for consistency's sake, that's completely fine, but you don't have to. So I, again, want a common denominator, so I'm going to make that 2 over 2. So then I have the square root of 2 minus the square root of 3 over 2, all over 2. Okay, now, I said earlier when I'm dividing by that 2, it's the same thing as doing what?
Multiplying by half.
Multiplying by half, so these two things are equivalent. Okay, the square root of 2 minus the square root of 3 over 2 times 1/2. Okay, I'm just doing this side by side here so you can see that those are equivalent, and that's the only thing that's happening there is basically rewriting it. So that's going to give me 2 minus square root of 3 over 4, which is all under that radical. Okay, I'm okay. So in the problem, I'm going to scroll back up for just a second. Okay, this problem that we did, I actually split this into 2 separate radicals. If you want to save a step of writing, I'm okay if you don't like actually write them as separate. I just wanted you to see that it was separate, okay, or that you can do that. So if you want to do that, that's fine. If you're like, I don't need to do that step, I can skip it. Totally okay. For the sake of it just being notes, I am going to go ahead and write it. But if that's something you could skip in your steps if you feel confident that you know what you're doing with that. So then top's going to still be the square root of 2 minus the square root of 3. And then the bottom, just going to take the square root of 4, which is 2. If I can write today, that'd be great. There we go. All right, so what I'm going to do with this next one is I am going to have you guys try one. Okay, now it's sine. We haven't done it yet. We haven't done a sine one. We've done cosine and we've done tangent. But I would like you to just... all of you do that, and it's so funny. In all my classes, when you drop something, they like move their whole desk instead of just getting up to get it. All right, I'm going to give you this next one, okay? There's a couple things about it. I'll write it and I'll talk about it, and then I'm going to have you guys try it, and then we'll go over it together. But it is the sine of 5 pi over 12, okay? Now, it's in radians, so I would convert it to degrees, okay? Look back at your sine formula and look at that. Okay, obviously you need to find half of whatever the degree value is. I'm going to hold off on working it at all until y'all are done, and then I'll work it for you guys as a whole. And then obviously make sure you find wherever this original angle is, if sine is positive, like if that value is positive or negative there, okay, that angle. Okay, so I'm going to let you guys do that for a couple minutes, and then we'll go over it.
Can we use half angle and or double angle, or just half angle?
Just use half angle for right now for this one. It might work out that you could use a double, but since we haven't done that, just use the half for this one. We'll use double angles with problem 17 through 20 when we get there. But after this one, we're going to be done for today, and I'll give you a couple problems that you can start on with this if you want, basically, just to get practice.
It's like, but do I want to? Not at all. Should I? Yes.
I mean, tomorrow we're going to do some other stuff with this, so, like, it would be good to make sure you understand how to use the formulas, but, like, at the same time, I'm not going to, like, just collect 3 problems, because that's all I'm giving you. So. Huh?
Like if the zeros, if it's like 0 over 2.
0. It's undefined if it's on the bottom. Go ahead and just write the angle stuff because I think y'all should be good with that. How are we doing? Go ahead and go over it. All right, so this formula, okay, is it going to be positive or negative? Where 75 lie? Okay, positive. Okay, I'm looking at where 75 is. So then we have 1 minus the cosine of 150 over 2. Okay, the cosine of 150 is what? Nope. Negative root 3 over 2. So this is going to be, it was negative and then it's negative root 3 over 2, so it's going to become positive. So then that common denominator on top is going to give me 2 plus square root of 3 over 2. And just to save myself a step, I'm dividing by 2, so I'm going to go ahead and do the multiply by 1/2 thing. So then 2 plus root 3 over 4. So then that gives me the square root of 2 plus the square root of 3, and then the square root of 4 is 2. And so then that would be my answer.
Confused myself because it was the sine of the number and then cosine of thing, and then I just can't.
All right, so 3, 5, and 7. Okay, so that's a sine one, a tangent one, and a cosine one. So that way you have one of each to try. Okay, y'all been doing pretty good with figuring out if the angle's positive or negative, so I'm not going to tell you, at least not right now.